Good morning. Today we are continuing our lecture on enzymology. So, what is enzyme? Anyone? Definition, please stand up. Say loudly. Usually, experience a train traveling through the tunnel. Tunnel is made usually in the mountain. Without tunnel, it is very difficult to climb in the mountain, to cross the mountain. Train requires much higher amount of energy to cross the mountain. Just like this, enzymes lower the activation energy. Okay? As an example, I can say, if you want to digest one piece of meat without enzyme, you can't believe it is take at least 24 to 36 hours to complete the digestion process. That is to break all the four-dimensional structure of the protein. Protein is made up of what? Peptide chain. That is very simple. Two amino acid held together by peptide linkage and then form a linear sequence, simple protein structure, that is called primary structure of protein, and then it start folding, that is called secondary structure. Again it start folding, that is called tertiary structure, and then again folding, that is called quaternary structure. By this way, this protein make a four-dimensional structure. Just remember like a thread. Okay, thread is you are winding and making a, that's like, this is four-dimensional structure of thread. Example. Okay. So, if you want to digest one piece of meat with the help of acid, a hydrochloric acid, you have to boil it for at least 100 degree temperature for at least 24 to 36 hours. Then you can achieve this. So tremendous time is taken. And also energy is taken to complete the digestion. But imagine inside our body, you eaten a piece of meat, within 1 hour or 1.5 hours, it is completely digested. This is the beauty of enzyme action. Enzyme is nothing but a machine. Okay? So the understanding the how the machine is working inside our body. Okay? So enzyme. Hello. Hello. So enzyme lowers the activation energy to the transitional state. Say this is without enzyme. This is without enzyme. Here, this is a substrate. Energy is providing here, and then without energy, ultimately reach into product. And then this is use of enzyme, which lowers this energy. This is called activation energy without enzyme. This is with enzyme or with enzyme. Okay. So first one is you have to write enzymes lower the activation energy. Do you understand, no, everyone? Understand? Any question? Okay. Again, come to second point. Enzyme favor the formation of transitional state. Okay? When substrate get attached with the active site of enzyme, okay, then it start to straining on the substrate. By this straining or stretching, whatever say, it distort the bond of the substrate. By this way, the substrate convert into product. stretching, straining, ultimately causes what? The distortion of the substrate. This is in transitional state. This is substrate, this is product. Okay? Transitional state means here the substrate get distorted, it is bond. By this way, substrate combined to product. Do you understand, na? Second line. You have to write 4 lines. If the question coming examination, you have to write at least 4 lines. First line is enzyme lower the activation energy. Preferably write this diagram. Okay. Then enzyme favor the formation of transitional state. How? As I told, you have to write 1 or 2 lines. Next, different theory about enzyme substrate complex formation. First theory is called lock and key model theory. Just like imagine lock, one lock and a key. Okay. So this is a rigid structure, lock and key. First proposed by Fischer. This is also called Fischer template theory. Say this is an enzyme. And this is a substrate. Just like if fitting this area, this is called active site of enzyme. Just fit in the area and get this structure. Okay, understand, na? Very simple diagram. This is called Fischer template theory, lock and key theory. But this theory is absolute nowadays, because this theory can explain how the Michaelis-Menten equation. I will talk after a few minutes. Just remember this name, Michaelis-Menten equation. And then come to second theory, that is called constant theory. It is like when substrate get attached to the active site of enzyme, it takes the shape of the active site. Just like you pressing your hand on a soft surface, like a piece of dough or wet ময়দা গুলা আর কি বুঝতে পারলে if you press this it take a shape just like a mud. If you take your pressing your hand it takes shape. Understand okay. So this is called constant theory. This is constant theory. You see, this is enzyme, this is active site of enzyme, and this pressed here and it take the shape. Pressing here take the shape. Constant theory. Okay. By this way, enzyme substrate complex form. Next is substrate strain theory. As I told earlier, when enzyme attached with the active site, substrate attached with the active site of enzyme, the substrate gets strained by the catalytic site of enzyme, and then it causes the change in the substrate, ultimately goes into product. When product released, again enzyme get into previous shape. You know, enzyme take part in the reaction, but after reaction complete, it get back its previous shape, like this. Okay, remember this. And then last one is actual catalysis. This is the main reason. Okay, in the catalytic site of enzyme, there are acidic and basic component of amino acids are there. Okay, the acidic amino acid get attached to the basic component of the substrate. Just A with B, vice versa, B with A. Understand? By this way, enzyme substrate complex form. Next is covalent catalysis. Example is just like remember HIV protease. This one enzyme present in HIV virus. Next is covalent bond formation. On the catalytic side, there is positive and negative ions are there. Positive ion gets attached with the negative ion of the substrate, and negative ion gets attached with the positive substrate of the substrate, vice versa. This is by the way covalent bond formation. Understand? Very simple. Okay. Example: cysteine, serine, histidine. These kind of amino acids are there. Okay. Some acidic subbasics like this. You will be teach during amino acid lectures. Which one is acidic? Which is basic amino acids? Understand? Next is proximity effect. What is proximity effect? This is just coming together and they start colluding with each other. Okay. When come together, they start colluding each other and then form enzyme substrate complex. This is called proximity effect or entropy effect. And substrate strain, I already discussed what is substrate strain. When substrate gets attached with the active site of enzyme, it gets strained and ultimately bond of the substrate get distorted, damaged or broken down, and then ultimately form into product. This is the mechanism action of enzyme action. Okay. So your question, if a question come in exam, can you understand? Can you read? Very simple. Okay. Next, very important topic. I am coming. Please listen carefully. This is one of the most difficult topic. Factors affecting enzyme activity, or others say, you can say what is enzyme kinetics. If you understand this, you can understand how the drugs are working in our body. Okay. So this point I will try to cover up today. Effect of substrate concentration, Michaelis-Menten Equation, Lineweaver-Burk Equation, significance of Km, order of reaction, effect of temperature, effect of pH. Okay. Look at this. This is the broad category. You can divide into two. Three important factors that affect enzyme activity are. Any question? Who is talking? Please listen carefully. First one is substrate concentration. Next, temperature and pH. What is pH? Anyone tell me? You read in the class 12 exam. pH? Any idea? Log of negative logarithm of hydrogen concentration. Okay? Okay. Let's move forward. Enzyme plus substrate. This is general formula. Enzyme plus substrate form enzyme substrate complex and ultimately enzyme plus product. This is general formula. From there it can be reversed by reverse. This is ultimately enzyme plus product. One product form you cannot back in its previous form. He may ask you, sir, so lot of products are there, you can generate again. How is it possible? This is because of different enzyme. Remember, I am talking about this only particular enzyme. Okay, that enzyme, the different enzyme. This is actually product is subset of that enzyme. Understand? What happened to you, backbench? Why you are talking? Please do not disturb others. If you are interested, you sit down there. If you don't have interest, you can go outside. Okay. Look at this diagram very carefully. There you can see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 enzymes are there. Among them, 2 enzymes, their active site get occupied with substrate. Other 1, 2, 3, 4, their catalytic site are free. And look at this. This is almost straight line. Here, the concentration of enzyme is greater than substrate. This is the reason every substrate get attached with the active site of enzyme. So, there the velocity of the formation of enzyme substrate complex is straight line. This is x-axis, this is y-axis. In this x-axis, this is denote concentration of the substrate in mole per liter or millimole per liter or picomole per liter, whatever. Okay, and this is the velocity of the enzyme reaction. Okay, this is mole per liter per second. Remember. Then you can see in this group of enzyme, all the catalytic site of enzyme get occupied with substrate. One substrate is actually free. It has no free enzyme available, so that it can get attached. So the curve is shift towards right side, little bit downside. Second group. In the last group, you can see all the enzymes are utilized, occupied by substrate, and lot of free substrate available. That is why the substrate concentration is much more higher than enzyme concentration. As a result, the velocity is reached into plateau. Okay, understand? Before going there, I would like to say some word. In our body, the number of enzymes is, each individual has specific number, like AGOT, it is a liver enzyme present in liver cells. The value of AGOT is 20 to 40 unit, okay, per ml or per liter, whatever it is. AGOT, AGPT, alkaline phosphatase, lot of enzymes are there inside body. Their number is specific. So in disease condition, if the number reaches high, some disease condition, and numbers are low in disease condition, maybe absent in disease condition. In inborn error of metabolism, some enzyme may be absent, some enzyme may be defective. Okay, in some cancer conditions, lot of abnormal enzymes made in our body by cancer cells. So I am talking about normal people has normal enzyme amount value. Understand? So here say substrate level is low, so the velocity is very high. Substrate level little bit higher, even more than enzyme, so velocity is starting to plateau. Here substrate was much greater than enzyme, so it reaches in plateau state. Okay, understand this one, everyone? Understand? Okay. So in this area, when we add excitement to substrate or excitement of enzyme, velocity is just like straight line, and sometime in some point velocity reach in a peak. Some point it is velocity is half. Okay, so how can you calculate this initial velocity? By this equation. Everyone should know this, memorize this equation. This is two scientists, Michaelis-Menten plot. They make this equation. V1 is equal to Vmax, that is maximum velocity, into substrate concentration divided by Km plus substrate. What is Km? Here, this is the Vmax, this is the half Vmax. Okay, half Vmax. If you plot this graph, you can see a straight line here. So, Km, this is called Km. Km means the substrate concentration where half velocity achieved by a enzyme reaction. Okay, everyone understand this, everyone? বুঝতে পারলে? সবাই বুঝতে পারলে? Km is the number is like this, mol or what, mol per liter. Okay, so here you can see the plot graph. The Vmax, half Vmax denote the Km. If you say plot here, that say here 2 is there, that is the Km of this particular enzyme reaction. So equation is V1 here is equal to Vmax times substrate concentration divided by Km plus substrate concentration. Okay? By this equation, you can calculate very easily the Km value. Say here Km value it is 2. If you have known any one of 2, you can calculate Vmax. The question is that half Vmax here 2, is it a 2 in plus 2 is equal to 4 Vmax? Is it? No. It's not like this. It's like Km times 5, that is Vmax. Km into 5, that is Vmax. Understand? 2 plus, understand? Km times 5. You should go through your textbook, otherwise you can confusion will be removed. Okay. So as I told earlier, Km is the substrate concentration where the half of the maximum velocity of enzyme activity achieved. Michaelis-Menten equation works only on simple enzymes because maximum enzyme has got some more than 2 subunits. Because as I told earlier, enzyme has 3-dimensional or 4-dimensional structure, they had subunits. So maximum enzyme decay cannot, this equation cannot follow by lot of enzymes. To achieve this, Lineweaver-Burk equation is come. Okay. Maximum enzyme has elasticity. There is multiple subunits. They doesn't follow Michaelis-Menten equation. Okay. Only simple enzyme follow Michaelis-Menten equation. But allosteric enzyme, that is, the enzyme has multiple subunits. They doesn't follow Michaelis-Menten equation. This is the disadvantages of this equation. So another disadvantage is that to achieve the maximum velocity, you have to add lot of substrate. But you remember, substrate are very expensive material. When I do ELISA test, we need substrate concentration, 10 ml or 20 ml substrate bottle or 50 ml, very costly, 4,000, 5,000 or 10,000 like this, very costly. And you have to put it in a freezer. You can't maximum substrate, you have to keep in freeze. Keep it maintained, otherwise substrate get destroyed. Okay. So in calculation, this will be quite difficult to achieve the Vmax by this equation. But Lineweaver-Burk equation, again explain how it is. How is the Lineweaver-Burk equation? This is the opposite of Michaelis-Menten equation. Okay, just like this. You can see Vmax, Vi is equal to Vmax in S divided by Km plus S. Just reverse this. Okay, there is called Lineweaver-Burk equation. Just reverse this. You can go through the textbook, otherwise you can understand. By this equation, you get very small amount of substrate required. But remember, there is reverse, everything reverse. Vmax 1 by Vmax. Km here is minus 1 by Km. Substrate also reverse 1 by S. If you add substrate, you can get 3.1, 2, 3. By this way, you can make a line, and by this line, you can easily calculate the Km value by Lineweaver-Burk equation. Okay. Any question till now? In research laboratory, we are using this formula to calculate the Km value of enzyme. Understand? You have to read several times, otherwise the conversion will be removed. Okay. Here given one equation, say Bmax, calculate Km, there it is minus 0.1 by 0.5. You just removing this negative value, you can see the opposite, 1 by 0.5, there is 2. Okay, like this. Understand? So this is Michaelis-Menten plot. Okay, initial velocity calculated by Vmax into substrate concentration divided by Km plus substrate. Km is the substrate concentration where half velocity achieved of a enzyme reaction. Understand? 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 Okay. Disadvantage is that simple enzyme work Michaelis-Menten equation, but maximum enzyme has allosteric. There is multiple subunits that doesn't follow equation. Another disadvantage is that to calculate the Vmax, you have to add lot of substrate, but substrate are quite expensive. So Lineweaver-Burk equation plot has solved this problem. What is Lineweaver-Burk equation? There is reverse of Michaelis-Menten equation or reciprocal of Michaelis-Menten equation. Just reverse this Michaelis-Menten equation. Understand? Advantages is that here very less substrate is used to calculate. Even 0.2 or 0.3 mole, very less. And another is that you can plot a graph like 3 or 4 dot by adding different substrate level. Understand? Okay. Please write down this significance of Km. What is the Km? Km signifies independent of enzyme concentration. This is the signature or characteristics of an enzyme. If anyone asks you in a question, what is Km? It denotes this significance. What is significance? There is signature of enzyme activity. There is a characteristic of enzyme activity. This is the affinity of the enzyme towards its substrate. So different enzyme has different Km value. Understand? Different enzyme has different Km value. Quoted by Michaelis-Menten equation. Disadvantage of Km value is that it follows only simple enzymes, but allosteric enzyme doesn't follow Michaelis-Menten equation. To come out this problem, Lineweaver-Burk equation come. What is Michaelis-Menten equation? That is Vmax into substrate concentration Vi, that is initial velocity, is equal to Vmax into substrate concentration divided by Km plus substrate concentration. What is Lineweaver-Burk equation? That is the reciprocal of Michaelis-Menten equation. There is reverse of Michaelis-Menten equation. What is the advantage? Lineweaver-Burk equation, very little amount of substrate required to calculate the Vmax. What is the significance of Km? Km denotes the characteristic of an enzyme, the affinity of this substrate. Okay, because enzymes are machine. Each machine has different power, different character. So here low Km means জাস্ট এবার রিটেন না, এবার রিটেন সবার লেখা হয়ে গেছে, লিখে নাও। Lower Km means high affinity towards substrate, high Km means lower affinity towards substrate. How is it possible? You can see here. If you go towards left side, the Km value affinity increased towards substrate. If you go right side, affinity decreases. Okay. Lower Km, there is higher the affinity of substrate. Higher Km value, there is lower affinity of substrate. Please remember this. Example is hexokinase has lower Km value. Both has same action. What is the function of hexokinase? Is an enzyme? Yes. Hexokinase function, glucose plus ATP forms glucose 6-phosphate plus ADP. Enzyme is hexokinase or glucokinase. Hexokinase present everywhere in your body. Glucokinase present liver and pancreas. Okay, but both have different affinity towards the substrate. Hexokinase has higher affinity, glucokinase is lower affinity. Please read this difference between hexokinase and glucokinase. This is one often asked question in your exam. Very frequent asked question in your exam. Glucokinase is called lower, higher Km value. Hexokinase has lower Km value. Please write this note, you can understand. Here you move left side, Km is low, affinity more. Okay, that means velocity maximum, left side, affinity more. Move right side, affinity less. Understand? Please don't talk, listen carefully. বলো। This simple just diagram में मैं आँकलाम এটা, just एक enzyme substrate complex. Initial velocity is maximum. If you go left side, initial velocity more. There is less Km. That is better the affinities. Right, more Km value, lower affinities. Understand? বুঝতে পারলে? Okay. Order of reaction. As I told earlier in previous 2 or 3 diagram, here all the enzymes and substrate they work first because enzyme concentration more here enzyme concentration very less. Okay, so here reaction velocity very high, that is called first order kinetic. Here all the enzyme occupied with substrate, some substrate waiting to attach to enzyme because once the enzyme gets free from its substrate after making product, then only it can attach with the substrate, enzyme. That is called saturation point. Here, if you add more substrate, the velocity cannot increase. That is called zero order kinetic. Okay. Okay, first order kinetics means when substrate concentration is much lesser than the Km value, there is a enzyme concentration. The velocity of reaction is approximately proportional to the substrate concentration. Is work like this, straight line. Again, in zero order kinetics, when substrate concentration is much greater than Km, the velocity constant and equal to Vmax. Velocity is constant and equal to Vmax. The rate of reaction is then independent of substrate concentration. Here, you add more substrate, you cannot increase the velocity. That is called zero order kinetic. Okay. Rate of reaction is directly proportional to enzyme concentration at the all substrate concentration. Can you understand this? No. Substrate V velocity. Okay. Initial, if you add more and more enzyme and more and more substrate, this curve is like this. Add more enzyme, more substrate, velocity increase proportionally. Okay. This is meaning rate of reaction is directly proportional to enzyme concentration at all substrate concentration. Understand? So this initial phase of reaction, that is called first order kinetic. In saturation point, that is called zero order kinetic. Okay? Understand? The maximum enzyme work in a 37 degree temperature. Okay, because maximum enzyme activate in 37 degree temperature, we have to maintain our temperature 37 degree because we are isothermic animal. Okay, lot of electron transport chain, ATP generating, phosphorylation, oxygen phosphorylation, glycolysis is there. We maintain our temperature constantly. Okay. So when temperature lower, in case of hypothermia, the enzyme activity decreases. Understand? When temperature reaches more than 42 degree temperature Celsius, then the activity start to decrease again. Because enzymes are protein in nature, they started denaturation. After 7 degree, almost completely inactivation occurs because the protein structure already get denatured. Some exception is there, like some bacterial bacillus thermophilus, they can work in high temperature. In PCR, we use one enzyme, DNA polymerase. It can work high temperature. These are some exceptions. But majority of enzyme work in this temperature, 35 to 40 degrees Celsius, remember. So, in temperature, we typically get is bell-shaped curve. Okay. This is the optimal temperature for human enzyme. But as the temperature increases, say after 25 to 25 degrees Celsius or 20 degrees Celsius, each 10 degrees Celsius increase, the reaction doubles. That is called Q10 is equal to 2. Each 10 degrees Celsius increase, the velocity increase 2 times. That is called Q10. Okay. Next is pH. Effect of pH. Majority of enzyme in our body work in this pH range, say 5 to 8. But some enzymes there, they can work lower pH, like pepsin. Okay. Pepsin is a digestive enzyme, is secreted from stomach. Okay. In acidic condition, like very low pH, 1 to 2, pepsinogen combine to pepsin, they activate and then start acting with this substrate. Okay, these are some exceptions. So, in order to digest some protein substances we eat, they require pepsin. Pepsin work in low pH. So, in our stomach, high acidity is there. Some drugs like PPI, proton pump inhibitor, they decreases the production of HCl, hydrochloric acid. PPI used in peptic ulcer or reflux esophagitis or GERD in this condition, dyspepsia. Okay. So when you use PPI continuously, the enzyme activity can disturbed. Have you heard the name some gaseous medicine? Bangladesh necho. Gaseous medicine. Amak kuch gas, हम gaseous medicine खाए. Continue खाले किंतु असुविधा होगा. People are taking lot of PPI without doctor's prescription. They are actually end up with digestive disturbance. Understand? And some enzymes work in higher pH, like alkaline phosphatase. Less pH means more acidic. And amino acid undergo protonation. They attract proton, H plus ion. pH more than pK, you will be learned in your acid base and pH classes, acid base classes. What is pH, what is pK? Just remember this. In pH more than, if pH more than pK, then amino acid undergo deprotonation. Just remember this word right now. Enzyme works, substrate concentration, what is first order kinetic, what is zero order kinetic, what is Km value. You have to go through this textbook today. Effect of pH, effect of temperature. Okay. What is the Michaelis-Menten Equation? What is Lineweaver-Burk equation? Okay, you go through this. Again, what is Michaelis-Menten equation? That is initial velocity is equal to Vmax into substrate concentration divided by Km plus what is Km? Km denotes half velocity of the enzyme activity. It is denoted as number what? Mole per liter, mole per liter. Yeah. Km denotes what? The characteristic of an enzyme. Less Km means more affinity towards substrate, high Km means less affinity towards substrates. Example, hexokinase, glucokinase. Hexokinase has less Km value, glucokinase has high Km value. 5 minutes only. Next, effect of pH. Change in the pH alters ionization state of functional group in the active site. You can take screenshot. Hence, effect on the rate of reaction. Each enzyme has its own optimal pH and function accordingly. Just like pepsin has low pH, alkaline phosphatase has high pH, salivary amylase has optimal about 6, pH 6. Extreme pH will denature the enzyme protein. Intracellular enzyme exhibit optimal pH value between 5 to 9. The relationship of enzyme activity to aspire ion concentration give a bell-shaped curve. Yeah, bell-shaped curve. Okay. Next, other factors like chloride ion. Chloride ion work with amylase. Some metals like magnesium ion, calcium ion work with ATPase. Metalloenzymes, there is metal containing enzymes like carbonic anhydrase, superoxide dismutase, they have zinc. Cytochrome oxidase, they have copper and iron. Okay. These factors also alter the enzymatic activity. Okay. Other factors like enzyme concentration itself, if we add more enzyme, that is velocity increase. But in our body, enzyme is limited. It is down only in outside, in laboratory. But in a disease condition, if more enzyme is formed, that is reaction may increase in disease condition. This enzyme is less in disease condition, the metabolism is lower because of that particular enzyme deficiency. Next is product concentration. When product is used to form, this product can alter or hamper the enzyme substrate complex formation. This is called feedback inhibition by product. Okay. Presence of activators or inhibitors like iron, some toxins, nerve toxins like this. Okay. Next is availability of coenzyme. Coenzymes are what? In previous class I told, maximum coenzymes are B vitamins. Coenzymes. Understand? These factors also influence enzymatic activity. Thank you.